You're alone in the workshop. Metal arms are already crushing your ribcage. Your ribs are cracking. The only shutdown button, 3 feet away from you. Will you try to reach it or wait to be crushed to death? 4 algorithms, 4 critical failures, 4 moments when cutting-edge technology turned deadly. You'll discover how a $90,000 humanoid robot's balancing system went into infinite loop mode. How Tesla's object recognition AI mistook an engineer for a car part. How a Korean robot's grip sensor calculated human flesh as vegetable packaging. These aren't sci-fi stories. These are real incidents that tech companies tried to hide, classified as minor malfunctions in official reports. But the final case will expose the terrifying truth. The problem isn't the robots going rogue. The problem is they're doing exactly what we programmed them to do. May 25th, Chinese robotics lab. 2 engineers are testing their newest creation, the Unitree H1 humanoid robot, 6 feet tall, human-like proportions, designed to work alongside people in factories, homes, everywhere. They hang it from a crane for safety testing. Standard procedure, nothing could go wrong. Then something goes terribly wrong. The robot suddenly starts thrashing, arms swinging wildly through the air, legs kicking with incredible force. It looks like it's having a violent seizure, but this is no malfunction. The robot thinks it's falling forever. Its electronic brain keeps screaming, "Balance, balance." And every second it gets more desperate, more violent in its attempts to save itself from a fall that would never end. A computer monitor explodes from a metal fist, then another. Sparks fly everywhere. The engineers scramble backward as this suspended nightmare destroys everything within reach. The sound is absolutely horrifying. Metal screaming against metal, electronics crackling and dying, like the robot is experiencing pure digital agony. But here's what's truly terrifying. The robot is doing exactly what it was programmed to do. It's trying to protect itself from a fall that will never come. Every wild swing, every desperate kick, it's all the robot's attempt to survive. For 31 seconds, the entire world watched a machine lose its mind. The video exploded across social media, 12 million views in days. People made jokes, shared Terminator memes, laughed at the crazy robot. But the engineers in that room weren't laughing. They were watching their creation panic, watching it fight against invisible demons only it could see. And then came the question that haunts every roboticist. What if that crane had broken? What if this panicking 6-foot metal human had crashed to the ground, with the engineers standing right there? The robot wasn't trying to hurt anyone. It was trying to save itself. And somehow that might be even more terrifying than a robot programmed to kill. If you're fascinated by these stories of technology gone wrong, hit that subscribe button. We've got 3 more cases that will completely change how you look at the robots already living among us. February 25th, Tianjin's Chinese New Year celebration. Thousands of families gather as Unitree showcases their H1 humanoids, a demonstration of cutting-edge computer vision and human interaction algorithms. An elderly woman approaches one of the robots, sweet grandmother, probably excited to see the future. The machine's LiDAR sensors detect her movement, neural networks processing her gestures in real time. She extends her hand toward the robot, a simple greeting that should trigger the friendly interaction protocol. You'd think this would be the perfect moment, right? Technology meeting human kindness, but the AI makes a critical error. The computer vision system misclassifies her gesture. Instead of recognizing an extended hand as a greeting, the object detection algorithm flags it as a potential threat. One grandmother's friendly wave becomes a secret alert in the robot's digital brain. Think this is just a minor glitch? Oh, it gets so much worse. The robot's threat assessment protocol activates. The humanoid's pathfinding algorithm calculates the shortest route to what is perceived as danger. Motion planning overrides the demonstration routine, switching to intervention mode. Now imagine you're in a crowd. You came to see cute robots. Instead, you're watching a 6-foot metal humanoid lock onto an elderly woman like she's a terrorist. The machine moves with terrifying mechanical efficiency. Security guards rush forward, but here's the thing, they're fighting algorithms that predict their every move. Multiple guards tackle the robot, wrestling with actuators that never get tired. Never give up. An emergency shutdown finally stops the nightmare, but the damage is done. Hundreds of witnesses just watched AI try to neutralize a grandmother. Engineers later found the bug. Training data had taught the AI that extended hands mean aggression. One mislabeled photo in millions. And suddenly, every greeting becomes a threat. The terrifying truth? This wasn't a malfunction. The robot did exactly what it was programmed to do. What do you think? Should AI be making split-second decisions about human behavior? Write in the comments if you trust a robot to tell the difference between a wave and an attack. November 2023, South Korea. Vegetable packaging facility. A systems engineer arrives to calibrate a robotic arm that handles pepper boxes. Standard quality control check. He's carrying a sample box to test the gripper's precision algorithms. The robot's computer vision immediately begins its scan. Weight sensors detect the correct mass. Optical sensors measure dimensions. Shape recognition confirms. Rectangular object. Standard packaging parameters. The AI classification system delivers its verdict with 99.7% confidence. Product box. You might think industrial robots are programmed more carefully than consumer models. You're about to discover how tragically wrong that assumption is. The robotic arm initiates its grab sequence. Pressure-sensitive grippers close around what the system identifies as a box, but those grippers are squeezing human flesh. The engineer tries to cry out, but the mechanical vise has already begun compressing his torso according to its programming parameters. This isn't random violence. This is precision engineering executing flawlessly. The robot calculates exactly how much force is needed to securely grip a pepper box. That same force, applied to human anatomy, becomes lethal in seconds. The arm lifts its cargo and positions it against the conveyor belt, applying the programmed compression force. The algorithm doesn't recognize screaming. It doesn't process pain. It simply follows its code. Grip, lift, compress, release. Task completed successfully. The robot returns to standby mode, ready for the next box. The official report listed workplace accident with head and chest trauma, but the technical reality is far more chilling. An engineer was processed by packaging algorithms designed for vegetables. Investigation findings? No software bugs. No hardware malfunctions. The robot performed exactly as programmed. Tesla Gigafactory, Texas. A software engineer is updating firmware on deactivated assembly robots. Standard maintenance procedure. All safety protocols engaged. Power systems supposedly offline. But one robot's power management system never received the shutdown command. An aluminum body assembly arm designed for precision automotive work. Hydraulic grippers rated for 440-pound lifting capacity. Equipped with hardened steel tips, engineered to puncture sheet metal with surgical precision. You probably think Tesla has the most advanced safety systems in the industry, right? Their AI is supposed to be years ahead of everyone else. The engineer doesn't hear the servo motors activating behind him. The robot's object recognition algorithm scans his silhouette, height correct, width within parameters. The machine learning model classifies him as an aluminum body panel, just another part to be moved along the assembly line. The decision tree executes. Grab object, relocate to next station. Those metal-piercing tips dig into human flesh exactly as designed. The engineer cries out, but the robot's audio sensors aren't programmed to recognize human distress signals. The grippers apply calculated pressure, perfect for metal handling, devastating for human tissue. Here's where it gets truly horrifying. The robot begins following its programmed route to the next assembly station, carrying what it believes is a car part. Two coworkers watch their colleague being transported across the factory floor by an algorithm that doesn't understand the difference between aluminum and flesh. Emergency protocols finally kick in when someone reaches the kill switch. Tesla's incident report? Minor laceration, left arm. No mention of puncture wounds from automotive grippers. No details about algorithmic misidentification of human workers. The company buried this story for 2 years, classifying it as routine workplace injury. But here's the question that should terrify you. If Tesla's AI can mistake a software engineer for a car part, what else is it getting wrong? 4 algorithms, 4 critical failures, 1 terrifying truth. AI doesn't see humans as humans. The Unitree robot's balancing system treated flesh like empty air. The festival robot classified a grandmother's wave as an attack. Korean packaging algorithms processed a human engineer like vegetable boxes. Tesla's assembly AI identified a programmer as a car part. These weren't glitches. These systems worked exactly as designed. They're already everywhere. Factories, hospitals, homes. Right now, millions of AI systems are making split-second decisions about what constitutes a threat or an object to move. In 5 years, these same algorithms will be in your car, deciding if that shape ahead is a speed bump or a child. In your smart home, determining if your movement is an intruder to neutralize. In surgical robots, classifying which tissue needs to be removed. Every day, we're teaching machines to make life and death decisions, and they're learning that humans are just objects with parameters. Subscribe for more stories about technology that's changing our world in ways we never imagined. And remember, you're surrounded by sensors right now. What do you think they see when they look at you?